All right, hello everybody. How are we doing today? So we're going to take a look at simplifying expressions today. And we're going to start by taking a look at a very simple concept, and that is combining things to make them simpler. So if I'm looking at all the different things on this page, I've got some crowns, I got some flowers, got some pennies, and we got kangaroos. Why? I don't know. Kangaroos are cool. Why not? So if I want to make this page simpler, the idea is I want to group some things together that are things that we would likely group. So if I'm taking a look at this, what do you think we could group on this page? Hopefully you're saying to yourself, well, of course we can combine the pennies because both of those groups are pennies, right? I can combine my crowns over here with the crowns down here because they're both crowns. Kangaroos, sorry, you guys are out. But the flowers, I can combine those two. So let's do that. I'm going to move things around a little bit here. I'm going to move these flowers down here. I'm going to move the pennies up there. Gonna move the crowns over here. And sorry, kangaroos, you guys are out. You guys are going to hang out over here because it seems like a cool place to hang out. Suddenly, this page looks a lot simpler, doesn't it? We've grouped the like items together, and no problem. Everything works out well. So now let's take a look at kind of the algebraic version of that. So let's say I have these items, and I want to make some detailed notes about what things are on this page and what things I can combine. And I want to express to somebody how to make things simpler. So variables are going to come in really, really handy here. So if I take a look at this little group of crowns over here, I notice there are 1, 2, 3, 4, 5, 6, 7 crowns. So algebraically speaking, if I call one crown C, I can say this group is 7C. And over here I have my two flowers, so I'm going to call that 2F, F representing flowers. And over here I have pennies, so I'm going to call this 4P because P for pennies, and I have four of them. Down here I got 3 pennies, so I'm going to make this 3P. And I can make this group down here, since I have 6 flowers, 6F. My 2 kangaroos up here are going to be 2K. And my 4 crowns down here are going to be 4C. So with these groups, algebraically speaking, I have every single group represented. And I can now come up with a total amount of items on this page, and I can combine things. So I can combine my 4 pennies with my 3 pennies. 4P and 3P will give me a total of 7P. Plus, I also have my 2 flowers up here and my 6 flowers down here, which gives me a total of 8 flowers, or 8F. I have my 7 crowns over here. I have my 4 crowns over here, which gives me a total of 11 crowns. And of course, my 2 kangaroos. They are hanging out. They are super happy. And we got 2K. That gives me my total. Algebraically speaking, I have 7 pennies, 8 flowers, 11 crowns, 2 kangaroos. Nice and simple. That is combining things algebraically. I can combine things if they have the same variable because the variable represents the same item. So let's take a look at algebra without the examples. So we talked about expressions the other day, expressions being combinations of numbers and or variables with operations. And I clearly have a whole bunch of things up here that are combined with operations. I have 5 minus 3y squared plus y plus x over 3. Each of these individual parts are called terms. And a term, very simply, is a number, a variable, or a product of numbers and variables. As long as I have a product of stuff or a single item, I have a term. In a term, when you have a mixture of variables and numbers, we call the number part the coefficient. We call the variable part the variable. I know it's crazy, hard to believe, but it's true. So a couple examples over here of like terms and unlike terms. So like terms would be two variables that have, or two expressions, two terms that have the same variable. So 3x and 2x are like terms because they both have an x, whereas 5x squared and 2x are not like terms. While it's true they both have an x squared is a different number. If I let x represent 2, then 2x means I have two 2's. But x squared is 2 times 2, so x squared is actually 4. 5x squared means I actually have 5 4's. And since that's a different amount, just like pennies versus kangaroos, can't combine these two together. That's crazy pants. Over here I have w and w over 7. Since they both have w's, they're like terms. 6a and 6b, obviously the variables are different, so they're not like terms. And likewise over here I have a 5 and a 1.8. Since there's no variable there, they're also considered like terms. They're like in that they don't have a variable. And likewise down here, 3.2 and n are not like terms because this one is literally a variable, and this one doesn't have any variables at all, and especially doesn't have an n. Sound good? Excellent. So like terms are terms of the same variables raised to the same exponents. That's our problem with our x squared versus x. Hopefully that's all making sense. We'll do one more little example down here. Say I have 5 treasure chests and 3 treasure chests. I can algebraically say it's 5 treasure chests plus 3 treasure chests, which should give me a total of, say it with me, 8 treasure chests. Very good. You guys are quick. I tell you, you're good. I wish I could be there to pat you on the head or give you a high five, but you guys are doing well. Now, algebraically speaking, I could certainly, instead of calling them treasure chests, I can call them 5x and 3x for 5 items and 3 of those same items. And again, I can combine these two together because they are like terms. I can merge them together and make it 8x. That's all we're really doing when we're simplifying expressions. So I got one more page to do, and then I'm going to separate this into a separate video. So in this list here, I want you to identify what the like terms are here. So if you need to pause the video for a second, pause the video, and just kind of point out which of these terms here, I have a whole bunch listed, which of these are like terms and which aren't like terms. Go ahead and pause it, identify them, and then unpause it when you're done. All right, hopefully you're back. Welcome back, by the way. I bet you did a really nice job. I bet you identified that the 3t and the 7t are like terms, and the 9v and the 8v are like terms, and that the w squareds are like terms. So hopefully you identified something like these groups. If you did, that means that we can combine these. So I'm going to give you an expression that involves each of those things. So right here, I have a big algebraic expression. I have those 1, 2, 3, 4, 5, 6 different terms all being combined with some pluses and minuses. Now, the like terms we said we can combine, right? So that's easy. If I take a look at this, I've got a bunch of different things that are like terms. I have my 3t here, and I have my 7t here. And when we're combining like terms, I always tell people that you've got to take the sign that's in front of the term with it. So I'm considering this a 3t and a positive 7t. Those two merge together to become a positive 10t. Now the reason that we have to take the sign with it is because of this pesky example here. I'm subtracting 5w squared, but if I'm going to move these terms around using our commutative property, technically I need addition. But we should know and remember that anytime you're subtracting, it's the same as adding negative, right? Hopefully you just said, yes, of course, Mr. Dorn, of course. Well, that means that this is really a negative 5w squared. So I'm going to take that negative with it, and I'm going to combine it over here with my positive 4w squared. And a negative 5w squared plus a positive 4w squared should give me a negative 1w squared. And of course, we have one more like term in here. I've got a positive 9v and a positive 8v, which gives me a positive 17v. That, my friends, is a nice simplified algebraic expression. I hope you enjoyed this experience, and I hope you learned a few things along the way. Thanks, guys. Until next time.